Hello everyone. In this module, we are going to be talking about the most popular word, and that is the scalability. So when you talk about scalability, so this is such a term which people is using in almost all the speeches left and right. So now let's understand that what it is. Is it really cool? Is it really complex? And what it takes to build a scalable application. So all of that we are going to be looking in this module. So when you talk about scalability, so what does it mean? So scalability means whenever we will be having any application, so we will see that initially, for any of the application, initially we are going to be having less users. Eventually, when app is going to gain the popularity, in that case, we are going to be having more users, right? So when you talk about scalability, so what we actually see that is this application having the ability to handle an increased number of users or transactions? Okay, so that is what we talk about it. Also, when we talk about dealing there, so we also see that for this application we are also going to be having some of its performance, right? So when we talk about the performance, so what we actually expect, if you are having, like, example, I'll take example of Zomato. So if you talk about Zomato, if today it is working with 100 users, what you expect, like you as a user, what you are going to be expecting, that I don't care if tomorrow you're going to be having some 1,000 customers, 1,000 people's using your application, but I want my experience to be working in the same state. So that is what is your real requirement, right? So if you talk about Instagram, so initially when Instagram came, not a lot of people were switching to that because Facebook was already having a great boom back then, right? But if you will see, slowly people started moving to it. But if you have been using it from the beginning itself, like I have been using it from the beginning itself, I can clearly see that the performance has not been degraded. The performance has always improved. They have improved the application in the various factors. They have added a lot of features there. But if you will see, the overall experience is still the same. So when we talk about increased number of users and transactions, so what we expect out of it, that performance should not be affected. So we can say that what is your scalability? That is your ability to handle increased number of users or transactions without dropping the performance. Okay, so that is what we mean by scalability. Many people, they think that they understand the concept and they use this word left and right. So they use this word scalability without knowing its meaning. I remember when I was a student, so scalability was such a word which I was using everywhere. If you have to talk about any software, okay, we are going to make it scalable. We are going to make it scalable. But to be honest, I never knew the exact meaning of that. If I talk about scalable, how in depth it is going to be working, I only got to know when I was learning the system design. So let us say that you are building any application. Okay, so initially you're going to be having some customers only. Okay, now in this case, let us say you are having a response time. Response time means if you are clicking on some place, if that application is having something like profile, so if you are moving to profile, so how much time it is going to take to respond for your request. So that is what we call as response time. So initially, let us say the response time was 5 milliseconds. Now as the application gained popularity, So what happened after that? We saw that your customers, like, let us say initially we had only three customers. Now what happened? After it gained popularity, so customer count became, let us say, 3 million. Okay. And now what happened? We have a bigger question here. Like, you guys can also pause your video and you can also think that after gaining so many customers, is the page going to load in the same time? Is the user experience going to remain unaffected? Is it still going to have a response time of 3 milliseconds, 5 milliseconds? So just like, you guys pause the video and think about it. Now, if your application can maintain the same response time, even if we have increased number of users, so we will say that it is scalable. If after having 3 million users, if the response time is still same, if it is still 5 milliseconds, in that case we say it is scalable, because irrespective of the user count, it is still working in the same manner. So that is when we call that we have a scalable application. In order to improve the performance, it is okay to put more machines. However, the key point is the performance. Your output, your SLA means service level agreement, your latency of the system. So all of these things should remain consistent. It should not be impacted because of the load. So when you talk about any application, so what are the factors which you should always be considering about its performance, about the output which you are getting out of it, about the SLA, like, your service level agreement. Also, if you talk about the latency of the system, so if your application is not impacted regardless of the load, so in that case, like if your application is still remaining consistent, so we will go ahead and call this application as a scalable application. So that is what is the meaning of scalable. So any application is going to be scalable if its performance remains stable when the load is increasing or decreasing. So whether they are few users or more users, the application should function smoothly. So if my application is meeting this criteria, I will label it as scalable. Like I'll give you one small example as well. So like, there was one series on physics wala that was there on Amazon Mini TV. So if you guys have seen it, like, I'll tell you what actually happened in that case. So that guy created a platform where he was delivering the video lectures. He didn't actually expect that he will gain a lot of users. He will gain a lot of students for his class. So what happened when he was starting his class, at that time his application got crashed. So as a spectator of that series, you guys must have not noticed that what actually impacted there. But the actual thing why that application was not working, that is because he didn't plan his application to take that much of load. When he was designing the application, he considered that maybe he'll get some 50 students, maybe he'll get some 60 students, but he actually ended up getting some 300 students or more than that. I don't remember the exact count, but that is what happened. So in that case, what we can say, his application was not scalable. That is why when the load increased, his application was not able to take that load. I hope it must be clear to all of you. Now we are going to be taking some more examples so that you can understand this concept even more. Okay. So I'll be taking the example of IRCTC. So you all must have used IRCTC application at least once in your lifetime. Or if you have not used, let me tell you what IRCTC is. You use this application if you want to book some train tickets. So when you talk about IRCTC, like, if you guys have already used, so you will have the fair idea about how it works. So like, if I had to talk about it, yeah, so if I have to talk about my opinion, IRCTC is not scalable application. So if you talk about me, like, especially like, if you have to talk about the Tatkal bookings. So what exactly happen if you know about the Tatkal booking? It is like they will be like, initially there will be certain seats for that train. After that, some people like, at the last minute, they will be canceling their tickets and all. So they are going to be opening a Tatkal window where you can go ahead and book those available seats. So generally like, that happens at 10 a.m. in the morning. So if you guys must have seen whenever you try to book any Tatkal booking, so in that case, the site slows down and the user is actually experiencing a poor performance there. Also, like, in such case, you will also see that transactions are frequently failing. So, like, I'll take my own example. So last year, I was booking a train ticket to Vishakhapatnam. So at that time, what happened? Me and one of my friend, we both were booking, and we thought that we were four people traveling there. So we thought that we both will book two tickets each, so that we will get lucky in booking the tickets. What happened for my friend, like, it actually happened by 1 second only. My friend was able to book two tickets, but when it came my turn, I could see transaction pending. After a while, I could see the booking did not complete, because as long as transaction is not complete, these seats are going to be still available and anybody else can come and book those. So that is what happened with us. So that is something which I can say, that its transactions fail whenever it is going to be experiencing more load. So this clearly indicates that IRCTC struggles to maintain performance when it will be under heavy load. On the other side, like, if you talk about the other timings, like apart from the Tatkal window, so at that particular time, it is going to operate smoothly. The performance is actually going to suffer significantly at the peak times, which shows that it cannot handle the high demand effectively. So scalability means that applications performance should remain consistent, whether the load is high or low. So in that case, I can go ahead and say IRCTC is not scalable, especially in the Tatkal window. Now I'll take another example. So like, I'm specifically talking about CBSE and your college websites. So I have done my schooling using CBSE, and when it was the board results timing. So at that particular time, what used to happen that when we were logging in to the websites, it was showing like, even when the results are released. So at that particular time, I was not able to see the results. The application was, the website was not loading. I have also seen some of the cases where people, like, if they have logged into the application in the early times, like, let us say the result got declared at 10 a.m. in the morning. So those guys who logged in around this time, they were still able to see the results. But if we talk about, let us say 10:05, at that time the website became slow, and as a result I can say these websites are not scalable. And same exactly happened even with the college website. So for uh, my college, like, I have done my BTech from Maharishi Dayanand University. So at that particular time, what exactly happened, our results got announced around 5:30 in the evening. At that time, I was at one of my friend's place and we were having some high speed internet. So the moment I got to know about the results, I immediately logged in and I was able to see the results. After a while, like, after 15 minutes, when everybody got to know that results are out, so they all were trying to logging into the website and they were not able to see. Then I got to know from the other fellow friends that they were able to see the results in the midnight. And why they were able to see it around that time? That is because around midnight, a lot of people will actually give up. They will feel that, okay, now let's sleep and we'll see it tomorrow. So at that time, the load decreased on the website, and as a result, they were able to see the results. So it's not about your internet is speed or slow, but it is about how many users are trying to access that portal. So that is how we can say your CBSE website is not scalable. I'll take another example for the scalable application. Okay, so that apart from this, like, so that you can understand that how you are actually going to be considering the performance there. So like, okay, let's take some application. Now, one thing is there, even if no matter how much good system design you are going to be using, one thing which you should always be keeping in your mind is no application is 100% scalable. There will always be challenges. So when you talk about scalability, so 100% scalable application is a myth. But one very good example of scalable application is Twitter. If you talk about traffic on Twitter, so what exactly is going to be there? So like, a lot of people are going to be using it, right? So if you talk about the traffic on Twitter, so that fluctuate dramatically due to the dynamic events. However, despite of these challenges, Twitter generally maintains a load performance. They maintain a stable performance throughout. So they may be only experiencing some slowdowns during the peak loads. So this flexibility in handling varying loads, so that we can go ahead and call that Twitter is a scalable application. Because in extreme peak cases only it is going to slow down. So like, little bit of slowness is still okay, but if it is more, that is something which is concerning, and we should be considering that in our mind, that if we face some of scalability issues, then how are we going to be addressing them out? Okay, the next one which we are going to be seeing is how can we achieve scalability. So we are going to see that if we have our machine, how can we go ahead and achieve it? So in order to achieve scalability, we have two ways. So the first one is your vertical scaling, and the other one is your horizontal scaling. So these are the two ways in which we can go ahead and achieve scaling. I will be explaining both of these to you so that you can understand that if you face some of the scenarios while working on any of the project, how you are going to be taking any action on the top of that. Or if in the interview, if people are going to give you some scenario and if they will ask you, how can we go ahead and improve our application? So you can tell that, okay, scaling is something which we can apply here. Now we are going to be discussing about vertical scaling. So, I'll be taking one example here so that you can understand it better. So, let us consider a scenario in the industry. Let us say we have a machine here. Okay. And let us say that this machine is having a storage of 500 GB. Now, initially, this application had a small number of users. And for that, 500 GB is more than sufficient. So now this is working for you, right? Because less users, good amount of storage, so everything is working fine. Now let us say that you have is let us say that this application is gaining popularity now. Let us say that you have cracked a way to the person's heart. So everybody is loving and liking the application. So what has happened? More and more people have started using the application. So as your application became popular, more users are going to start using it, right? So the amount of data generated is naturally going to increase, correct? So now let us say that out of this 500 GB, you have consumed the 80% of your storage capacity. So based on the current trends and calculation, you will realize that if you are not going to make any changes, your database is going to get full in the next 2 weeks. So clearly you need to find out a solution to increase your storage capacity. So what you will do, you can also take the example of your phone. Okay, if you have your phone, if you will see the storage is getting full and you do not have the option of clearing it off, what we do, we take the backup of the pictures and then we clear off that storage so that your phone can have more storage. What you will do, or your laptop is running out of storage, so what you will do, in the real life, like, what you are going to be doing for your laptop, you are going to put external hard disk. You are going to be putting some external storage there so that you can divide the data. Correct? So that is what you are going to be doing in such a situation. Now, if you talk about this application, so implementing a distributed system can be an option where you can put some of your data, like, if you talk about that phone thing, so instead of putting everything on one phone, what you can do, you can go ahead and put it across the different phones, right? So this is one of the solution. But if you will see, in such case, initially, if you were managing one phone, let us say one phone is costing you somewhere around 30K. If you are buying five more phones, that is going to charge you more, right? So still that is an option. But for that, what you will have to do, you will actually be spending more money. Secondly, you will have to change the entire application. So that is something which is not practical in this case, right? So for this application, straight away going for the distributed system is something which is not practical, right? What is the immediate solution? So immediate solution, like I said, for the laptop, what we can do, we can add more memory. So here also for this machine, what we will be doing, we are going to add more storage. Correct? This is the option which you are going to be following here. So in the existing machine, you will go ahead and add more memory. So how you can solve this problem? How this problem got solved? By adding extra storage here. By increasing the capacity, you are still able to make this work. So here initially, if your application was having 500 GB, and now what you can do, like, in the laptops as well, we have the option of putting some external hard disk and some memory chips and all. So what you have done, like even in the phones, you have the option of putting some memory cards. So what you have done, initially it had 500 GB, now you have added another 500 GB here. So if you add another 500 GB to your current setup, this method is called as vertical scaling. So when you are going to be adding it like this, we will say that we have vertically scaled our system. We are vertically scaling here, okay? Because you are scaling up in the vertical direction. So by enhancing the existing resource, what we have achieved here, we have achieved vertical scaling here. So initially your machine had a storage of 500 GB. Now on the top of that, I have added another 500 GB. So overall, how much storage you have here? 1000 GB. So what you have achieved here? Vertical scaling, correct? So when you try to maintain the performance of the system by increasing the capacity or configuration of the same system, so this way of scaling is called as vertical scaling. So overall, the major intent of performing these things is to scale the performance. What we want, even if more users are going to be using our application, we are still be able to take that load. Now, if we are if we have consumed 80% of this storage, we still have another 500 GB added there. So we have increased the capacity, we have increased the configuration of the same system. So this way of scaling is called as vertical scaling. Now, another question is, can we continue vertical scaling indefinitely? Like, if, like, what will exactly happen, like, now what I have done, I thought that okay, I'll add another 500 GB to my machine, but is this going to be the solution for a longer run? Like, if today I have some 500 users, if tomorrow I'll have 5 million users, can I continue doing the same? Are there going to be any constraints of achieving vertical scaling there? So the answer is no, and there are two main reasons for this. What is the first reason? The first one is hardware limitation. I'll take the example of phone here first. So if you have your phone, for that, let us say you have two slots for memory card. Just consider this scenario, okay? So now what you have done, initially when you ran out of storage, you added one memory card here. Eventually when you saw it again got full. So what you have done, you have added one more there. So that is how you can do it, but it has limitation here that after two memory cards, I cannot go ahead and put another memory card here because we do not have option of putting that. So that is the limitation which I have at the hardware level. So similarly, when you talk about this application, so there we have a limit for your RAM and for your CPU. So up to that limit only, we can go ahead and increase these things. There is going to be a limit to which your RAM and CPU can be increased. And this you can be like, this is something which is actually limiting based upon the hardware capabilities. So if you have a machine, you can just put the storage up to some extent only. Like I have a machine. After that, I even bought a hard disk of 5 TB. And let us say I always plug into my machine and that's how I use it. But I have a limitation here that I can only be having some two USB ports. So I can maximum put two USBs there, right? So that is how I have that problem here. And how that problem is there because of the hardware capabilities. So similarly, when you talk about the same, like, if you have any application, so there is going to be a limit up to which only you can go ahead and increase your RAM and CPU. Now, the next one which we have here is your cost considerations. So when you talk about cost consideration, like what exactly is there? So if you talk about any of the company, so what is the ultimate goal for any of the company? If you are a shopkeeper, if you are selling some goods, what is your ultimate goal? To make profit. Similarly, if you talk about any of the company, so what is the wholesome purpose of any of the companies? That they go ahead and make profit. So if we are making any investment by adding some extra infrastructure, this investment should help the company from the perspective of making more profit, right? Now, as a part of any company, your goal is going to be making the profit here. And if you talk about the studies which we have done for the vertical scaling, that initially it can be effective. Like, let us say that you have a small startup. In that case, of course, there is going to be a cost limitation also. If you think about putting it on the distributed system, that is not at all going to be a feasible solution, right? So for a startup, it's going to be a wise decision, and it is even going to be effective if you are performing vertical scaling, if you are adding up some memory there. So that is going to allow you for the increased computation, and that is also going to be helping you in improved performance. But as the load is going to increase, this approach is also going to having some limitation. So eventually the benefits of vertical scaling diminish as we increase the cost and when hardware limitations are reached. So what do I mean? Like, for any of the application, how it is actually going to be there. You are going to be having some load. On the top of that, you are also going to be having some configuration. Correct? Now, what will happen initially when the load has increased and when you have increased the configuration? So, your performance is also going to increase, but eventually, after that, it will also slow down. So initially, when you go ahead and implement vertical scaling, so what happens? The performance remain the same. But eventually, like, what will happen? Over the period of time, you will notice that here also the performance fails. So if you will see, this is not like, this is the peak point till which we can see we have experienced high performance. After that, the performance is falling. So what is happening here? Your performance is falling gradually. So while this is still fine, this gradient is still okay. If you will see, the gradient is not huge. It is very less only. So when that gradient is still going to be less, the situation is still going to be manageable. But the problem is that if you do the vertical scaling and if you try to compare the performance and cost economics, then in the beginning it is linear. It means that if you are investing more in the vertical scaling, you will see that eventually, you will see that there is a proportional improvement in the performance, but eventually after a period of time it will start curving. So after a certain point the performance gain diminishes in correspond to the increased cost, and that is going to lead to less efficient scaling approach. So if what do I exactly mean, I'll just draw it for a better clarity. So when we are, here we are considering the cost and here we are considering the performance. So what I am saying that initially with the increase in cost the performance is also going to be there. So here we are talking about the delta in cost, the difference in the cost which is happening. And here if you will talk, here we are talking about the performance. So here we are going to be talking about the change in the performance. So initially your change in performance is your change in the performance is going to be directly proportional to the change in the cost. But after a point, if you will see that when you are increasing the cost of the vertical scaling, your delta C is going to be proportional to the increase in the performance. So if your performance is increasing, your cost will also increase. So initially it is going to be proportional, correct? But after a while, you will see that, as long as this happens, as long as with increase in performance, you are getting, when you are increasing the cost, your performance is also increasing. So as long as you are getting this, you will still say that it is beneficial for me to keep it doing. In the other words, what we can exactly say that your change in performance is directly proportional to your change in cost. It means that your performance improvement is proportional to the cost involved. How much money you are putting in the terms of cost, that is going to be helping you in the increased performance. So as long as you are getting some profit out of it, then it is okay to scale it vertically because you're putting some money and you are getting some profit out of it. Similarly, if you talk about any of the business, if you are putting some money there, if you are going to get some profit out of it, you are still going to be okay, right? But when it is not at all going to be okay, let us say after this point, what exactly happened? Now you are increasing more cost. But if you will see, there is a dip in the performance. Like we are not getting that much of performance out of the cost which we are doing here. So after a point, we will see that the increase in performance becomes minimal as compared to the rising cost. So initially what will happen if you are increasing, let us say you are increasing the cost by 100, so you are going to get a profit of 100. So you can say that it is directly proportional. Like when I am increasing the cost, I am increasing the profit as well. So the overall performance is also increased. But after a while, what you have seen, if I am putting 100 for my cost, I am getting only 30 as the profit. So is it still going to be beneficial? No, right? So what you have is seen here, with the increase in the cost, there is less increase in performance. And this is something which we are not going to be considering because overall we just want to make more profit. So if you are if you're talking about some of the business which you have set up, so if you will see that you are investing more money but you are getting less returns in the performance, so this situation is not at all going to be a wise decision, right? If we are having some company, so what we will feel that we can be changing our methods, we should be seeing how we can improve our profit here, right? So in that case what you will have to do a trade-off between cost and performance. You will have to decide what you want to do here. Either you are going to be considering the cost or you are going to be considering the performance. Okay. So I hope this must be clear to you what exactly happened. When initially you were increasing the cost, the performance was also increasing. After a while, what happened? You were putting more money in order to improve the infrastructure, but you were getting less performance out of it. So that is not a wise decision. Now, there is one more reason to avoid vertical scaling. And what is that? People say that, even if you talk about stocks and all, people say that don't put all your eggs in the same basket. Correct? They say that if you want to perform some investment, instead of putting all your money on one stock, it's better if you will split it across different stocks, because you are not going to be risking your entire money on one thing. Instead, you are going to be seeing how individually everything is performing, right? The same logic applies even here as well. So when you do vertical scaling on just one system, you have, if you talk about your application here, you have one system here, right? That is what your vertical scaling is. So what you have done, you have taken one system here, you have added all your money here, correct? You have put all your expertise here, right? All your data, like whatever data you have, all of that you have put on one machine, right? So we cannot take guarantee of anything, right? This machine, if we have a machine, we this machine can still go down. What does it mean? There can be some power failure, right? Your machine can also crash. All of these things can happen. Since you are putting everything in one place, it means that what is exactly happening here? Here we have single point of failure. I'll take another example here so that you can understand this situation better. Let us say that you are on a vacation. You have one phone with you. Now in that phone, what you have done, you have installed. Yeah. So I was saying that let us say you are on a vacation. You have one phone with you. Now what you have done in this phone, you have added all for that country. Let us say you have added all food applications there. You have added all, cab booking applications there. You have also put your translator there. Now what can happen? If you are having everything in one phone, what will happen? There could be a situation of failure for this phone. What are the possible failures for this phone? Battery, no battery, correct? Another one is, let us say, there is no network. What could be another failure for this phone? Let us say phone broke. So now what will happen if you will put everything in one phone? If any of these things are happening, so what will happen? You have a single point of failure here. Means if your phone is not working, let us say your phone broke on your trip and you are in a group of two people, what you have done, now phone is broken. Now if you want to communicate to someone, so the translator app was also there in that phone only, that application will not work, right? Instead, what you would have done, instead of putting everything in one place, if you would have done it in two phones, would that have worked? That would have worked, right? Because if one machine is not up, if one phone is not working for any XYZ reason, still you have the option of another phone. Correct? So I hope with the help of this example, it must be clear to you. So if you will keep on doing, in this phone, let us say initially it had a 256 GB of storage. What you have done, you have added another 256 GB, and you thought that instead of carrying two phones, I'll be only carrying one phone. And because now it is having additional storage as well, so it will be easier for me to click all the pictures and all, and I will be all sorted in my trip. But if you will see here, even after having all these things, you still have a single point of failure. So similarly, when you talk about this, when you perform vertical scaling, so it can be beneficial in a short term. This thing could have worked if you are just doing it for 1 hour or 2 hour, like right? So similarly, when you talk about the vertical scaling, that can be beneficial in the short term, but over the period of time, we should be thinking something beyond this. Everyone clear how we perform scalability? Okay. Now there is one more thing which I really want to discuss out here. That is scalability a good problem or bad? Everyone just pause and try to think about it. I am saying that I have scalability problem. So is it even a good problem or bad problem, even for the companies to solve? I hope you guys must have thought about it and now you have resumed the video. So, when you talk about scalability, so what exactly we mean by scalability? I told you, right? So, if you are having any application, if today you have less users, tomorrow if you are having more users, so overall the performance should remain same. That is what we mean by scalability, right? Now, if our application initially had 30 users, now if it is having 300 users and we are facing some performance issue, so is it a good problem or bad? Of course it is a good problem. Why? Because it's good, right, for us, for our application, that initially it had 30 users, now it is having 300 users. Similarly, for any of the applications, scalability is always a good problem to solve, because it's good that we are having more users for our application. It indicates that more users are engaging with our application. So this is a positive sign of growth. Correct? Right? So this means we are growing. So since vertical scaling is not helpful always, it has some limitation. Then we should move from the centralized system. We should be moving to the centralized system, from the centralized system, and we should be moving towards the distributed system. And that is what we call as horizontal scaling. Like I said, instead of keeping everything in one phone, what if you are two people? So what you are saying that I am going to be installing same set of apps. Here you will be having cab apps, you will be having food, you will be having translator. Here also you will be having cab, food, translator. So all of those things you are putting in both of the phones. So what you have done, instead of putting everything in one machine, instead of having a centralized system, now what you are doing, you are putting it in a distributed system. You are distributing it out. Instead of putting everything in one machine, you distribute it out. So this is what we go ahead and call it as horizontal scaling. So what is horizontal scaling? So here what we do, instead of one machine, we make use of multiple machines. So instead of one machine, we will make use of multiple machines to increase the scalability. Correct? So previously what we were doing, on one machine, we were adding more memory. Here what we will be doing, if we are having initially a system of 500 GB, and let us say that now we require a storage of 2000 GB. So what we will be doing, instead of putting everything on one machine, now we are going to be splitting it across different machines. Now what we are doing, at every machine, I am going to be putting some 400 GB. And we are going to be connecting all of these devices together. How can I connect? We can connect all of these devices over the network. So this is how all the machines are going to get connected to each other. So here what we do, when we have this kind of setup, we say that we are having cluster of machines. We go ahead and call as a distributed system. So I hope this must be clear to you what we are doing. Instead of putting everything in one machine, now I am making use of multiple machines to store the data. And then when we follow this kind of strategy, what we do, we go ahead and call it as horizontal scaling. Now let's see what are the benefits of using horizontal scaling. So when you talk about horizontal scaling, what is the best part about horizontal scaling? Can you guys think of it? The best part about horizontal scaling is that here we have flexibility, correct? If my current load is 200, let us say I have a current load of 200 requests per second. Yeah. So now let us say that we have a current load of 200 requests per second. And let us say that this load has increased to 400 requests per second. So I can easily add more machines to handle the increased demand, right? Also, if tomorrow load is going to decrease, then I can remove some of the machines accordingly. So depending upon the load, if you have more load, so what you can do, you can increase machines, correct? If you are having decreased load, then you can decrease the count of machines, correct? So depending upon the load, we can actually see how we should be taking up the action. If load is more, we can use more machines. If it is less, then we can use less machines. But overall, which one thing which we always have to consider, that is performance should remain same, correct? We should not be impacting the performance. So when we have this ability to scale up or down based upon the load, then we say that we are performing horizontal scaling. Our ultimate goal is to maintain consistent performance regardless of the fluctuations which we are going to be having based upon the demand. So, when we are going to be adding or removing the machines automatically, we are going to be setting up our systems in such a way that based upon the load, what I will, what generally happens, if there is some application, we are going to be having some set of machines. And based upon the loads, we will decide how many machines to use accordingly. There are going to be certain machines available and we are going to be adding or removing based upon the load. So when we go ahead and use such a system, we say that we have elastically scale them. So when you talk about elastic scaling, what does it mean? It means that such machines are going to be able to handle such of the situation when you have to add or remove machines, that too automatically, correct? This feature is generally offered by some of the cloud providers. What and all are offering this? So if you talk about your AWS, if you talk about Azure, if you talk about Google Cloud, so all of these are actually providing you this flexibility. So here, if you have seen what we are doing based upon the requirement, we are going ahead and we are performing scaling, scaling here. Based upon the load, we are going to be adding or removing the machines. But overall, what is our ultimate goal? What is the key feature which we expect out of it? That the performance should remain same, right? So now let me just brief down the scalability and then we will be winding up the module. So whenever you want to achieve scalability in any of your application, so how you can do? You are going to be achieving it at the code level and at the infrastructure level. These are the two ways of achieving it, right? Correct. These are the two ways in which you can go ahead and scale down your application, scale up your application. Now, when you talk about code level, what are the two ways of achieving it? So that is something which we do by taking care of the time complexity and your space complexity. Correct? These are the two ways of achieving scalability at the code level. When you talk about infrastructure level, at that time we can achieve it in two ways. What and all those are? So we have seen first one which we have seen is your vertical scaling, and the other one which we have is your horizontal scaling. So these are the two ways in which at the infrastructure level you can go ahead and perform the vertical scaling. And you perform the scaling at the infrastructure level. Okay. Now, when you talk about horizontal scaling, what is the one thing which we always take care here? So in the horizontal, like, if you talk about vertical scaling, so there what we are doing, we are putting all our eggs at one place. So what we are doing there, we are actually having one machine where we are going to be putting everything. So if that machine is going to go down, the entire system will go down, right? On the other side, when you talk about horizontal scaling, so this one is fault tolerant. Here, if there is going to be any fault, it is going to handle it down. And how it will be able to achieve that? With the help of replication. This replication is something which we are going to be covering in our next module. But I hope it must be clear to you that if we are going to be encountering any performance related issue, in that case, how can we go ahead and optimize your system, like how you can scale your system, right? Now I will be seeing you in the next module. Till then, happy learning. Bye bye.